evaluating the indefinite integral. Just going to add 1. That's going to give me 3x cubed. Then you divide by the power over 3. Don't forget to add 1 to the 1 there. This is going to give me 2x squared. Divide by the power plus 7x. Don't forget to add the c. So that's going to generate a final answer of x cubed plus x squared plus 7x plus c. A little bit more involved. I'm going to rewrite this in exponential form, bring that up. No, I'm not going to bring that up. I'm going to leave that. I'm going to rewrite this in exponential form. So this is going to give me the integral of x to the 1/2 plus the integral 7 times 1 over x plus the integral of x to the 1/3. I should have a dx after each of these, but I'm going to hang out with that. I'm going to add 1 to 1/2, and that's going to give me x to the 3/2. But then I have to divide it by 3/2 as well. Plus, the integral of 1 over x is just ln x, so that's going to give me 7 ln x. Plus, I add 1 to that. That's going to be x to the 4/3. But then I divide by 4/3. So I'm going to spruce my answer up a little, and this is going to generate the reciprocal. 2/3 x to the 3/2 plus 7 ln x plus the reciprocal 3/4 x to the 4/3 plus c. Don't forget to add c. This one's easier than it looks. No fancy use substitution or anything. I'm just going to kind of pretzel this and divide. So that's going to give you a new integral of x squared over x squared, which is 1, plus the integral of 1 over x squared. This integral is kind of easy. That's just going to give me x. But this one I want to rewrite with a negative exponent. So I'm going to get a final simplified integral of 1 plus x to the negative 2 with respect to x. Integral of 1 is just x. I'm going to add 1 to negative 2. So this is going to give me plus x to the negative 1 divided by negative 1 plus c. Let me write my answer down. X minus, I'm going to rewrite that with a positive exponent, 1 over x plus c. I could use u sub or just FOIL that out. I'm going to FOIL it out. It's going to give me an integral of x squared plus 8x plus 16. And then just take the integral. I'm not even going to show work for this. That's going to be x to the 3rd over 3. This here is going to be x squared. 8x squared over 2 is going to give me plus 4x squared plus 16x plus c. All I did was I added 1. That gives me x cubed over 3. There's a 1 there. I add 1 to that. That gives me 8x squared divided by the exponent. And that's where I got my 4 from. And then plus 16x. And add the c. I'm going to use u sub for this. I know I don't have a let u equal, but I'm going to use u sub. I'm going to let u equal 5x minus 1. The derivative of u is going to equal 5 dx. So I can rewrite this when I divide both sides by 5 as 1/5 square root u, or u to the 1/2, du in the u world now. The integral of u to the 1/2, don't forget I have to add 1 to that. So that's going to give me 3/2. 1/5 u to the 3/2. And then I'm supposed to divide this by 2/3. I'm sorry, divide this by 3/2. I'm just going to multiply it by the reciprocal right off the start. Plus c. So this is going to give me 2 over 15 u to the 3/2 plus c. But u, we found out the equal was 5x minus 1. I'm going to rewrite that in radical form. So it's going to give me 2 over 15. The square root of that cubed. Let me see here. The square root of a quantity cubed. That means I can pull one of those out. That's 5x minus 1 squared times 5x minus 1. So this is going to give me 5x minus 1 square root 5x minus 1. Whoops. Outside the radical plus c. Going to do a simple u sub. I'm going to let u equal the innermost or the most complicated in this case. It's going to be x to the 5th plus 1. When I take the derivative of u, that gives me 5x to the 4th dx. I need to have an x to the 4th dx, and I have an x to the 4th dx. They're going to cancel out. But I have this 5 hanging out. So to get it into u world, I have to divide both sides by 5. And notice, this is going to give me a new integral. 1/5. I let u equal x to the 5th plus 1. So this is just going to be u to the 7th in the u world du. Take the integral of u to the 7th, I add 1. That's going to be u to the 8th, divided by 8. So I'm going to start writing it over here, u to the 8th, divided by 8, but times 1 over 5. And let's not forget that u equaled x to the 5th plus 1. So this is going to give me 1 over 40, x to the 5th plus 1, to the 8th plus c. Let me copy that answer down. 1/4, x to the 5th plus 1, to the 8th plus c. I wouldn't want to FOIL that out. I wouldn't want to FOIL that out and then distribute. I'd rather just use the u sub. Number 7, this time I'm going to let u equal x cubed plus 1. I'm going to take the derivative of both sides. Du is going to equal 3x squared dx. Notice my x squared dx will simplify, but I have to divide both sides by 3. And this is going to give me a new integral with 1 over 3 in front. U, square root of u, or u to the 1/2. In the u world, du. I'm going to add 1 to that, which is going to give me 1/3 u to the 3/2 times the reciprocal of that. And this is going to give me 2/9. Substitute a u in, which is x cubed plus 1 to the 3/2. And as we noticed before, when I write this as a radical, it's going to give me 2/9, one item on the outside, and the square root of the item on the inside. Don't forget, close the radical, plus c. I believe I'm going to let u equal 3x cubed minus 5x. Take the derivative. That's going to give me 9x squared minus 5 dx. Notice this whole quantity will cancel out with the 9x. I forgot to put a dx out here. It's supposed to cancel with the dx also. So this is just going to give me 1 over whatever I let u equal, 1 over u. In the u world, du. The integral of 1 over u is going to give me ln of u plus c. But don't forget, I'm going to plug this back in. So my final answer is going to be ln of 3x cubed minus 5x plus c. For this one, I'm going to use synthetic division to find the integral. So remember, you put the opposite of what's on the bottom in this little backwards box. And then you write down the coefficients, 1, 6, and 8. Now I'm going to implement the synthetic process. Bring down the 1, that's negative 1, that's 5, that's negative 5. That's going to give me a remainder of 3. So I'm going to get x plus 5 plus 3 over x plus 1. And now that's going to be my new integral of this whole quantity. And notice, I couldn't have used u sub or anything fancy over here, but now this integral is not that bad. The integral of x is x squared over 2. The integral of 5 is 5x. And the integral of 3 over x plus 1 is 3 ln x plus 1. Don't forget, since we're done, plus c. Same process. Notice I can't use u sub, so I'm going to do synthetic. I'm going to set up my backwards box, and I'm going to put the opposite negative 1, which is positive 1, in my backwards box. And then I'm going to put the coefficient 1 and 5. Put a 0. Pretty short synthetic process on this one. 1 times 1 is 1. I add them, that's going to give a remainder of 6. So this integral is going to be x plus 6 over x minus 1. Not too difficult to find the integral of. So the integral of x is going to be x squared over 2. The integral of 6 over x minus 1 is going to be plus 6 ln x minus 1 plus c.
For number 11, this one's special. I can't use u substitution when I have to use a method called integration by parts. But I use a different method called the tabular method. And what you do is you take the x squared and you're going to keep taking the derivative of x squared. And then you take the sine x and you're going to be taking the integral of sine x. And you're going to continue down until you reach a repeat or a 0. So the integral of sine x and the derivative of x squared. Well, the derivative of x squared is 2x. Then I'm going to take the derivative of that again, which is 2. And the derivative of 2 is 0, and that's my stop. I'm going to stop there. Now I'm going to take the integral of of sine x. And the antiderivative of sine x, and I have to be careful, is negative cosine x. Now, the antiderivative of cosine x is sine x, but the antiderivative of negative cosine x is going to be negative sine x. Now, the integral or antiderivative of sine x is negative cosine x, so this is going to be a negative negative, so that's going to give me cosine x. Now, the diagonals are the answers, but before I do that, I have to alternate a plus, minus, plus, minus. So it's going to be positive x squared times negative cosine x. So my integral is going to be negative x squared cosine x. Negative, negative. So plus 2x sine x. And then positive times a positive is plus 2 cosine x, and I'm done, so I'm going to hit plus C. I don't even know if I can fit that answer over here on the answer line, but I'm going to try. So the deal is, using Occam's razor, I would never have the negative leading first, so I'm going to start off with my 2x sine x. I'm going to start off with my 2x sine x. 2x sine x minus x squared cosine x plus 2 cosine x. Don't forget, plus C. I just barely fit it.